Okay, so let's evaluate this integral here. Okay, so evaluate this integral defined as 1 minus x squared minus y squared. So that's going to be a paraboloid, right? So we're basically finding the volume under this negative 1, 1, 1, negative 1, right? Of course, this paraboloid goes down, but we're looking for above the xy plane, right? So R is the unit circle in the plane. So this integral is just going to evaluate the volume of this region here, and then in xy plane, we have the unit circle. Okay, so in the unit circle, 1 and 1, obviously R is going to run from 0 to 1. It's a unit circle. The radius at most is 1. Okay, and theta is going to run from 0 to 2 pi. How do we describe this circle? Where theta has to go full circle, right? Okay, so two things we have to do here. First of all, we have to express z in terms of r and theta. Okay, so let's do that. 1 minus x squared minus y squared is equal to 1 minus x squared plus y squared. And in polar coordinates, x squared plus y squared is r squared, right? X is equal to r cosine theta, y is equal to r sine theta, and we have done this, right? X squared plus y squared is r squared cosine squared theta plus sine squared theta, which is r squared. That's the last time I'm writing this. You should know it from now, okay? So this integral here becomes the double integral of 1 minus r squared, 1 minus r squared. And now be careful, we're switching into polar coordinates. So I have to multiply it by r dr d theta. Okay? R runs from 0 to 1, theta runs from 0 to 2 pi, and this is straightforward. You can just evaluate this quite easily. You can see that r is independent of pi, so this is going to be just, or you don't have to do it like that. You don't have to rush from 0 to 2 pi. This is 1 times r is r, integral of r is 1/2 r squared minus r cubed, integral of r cubed is 1 over 4, r to power 4, evaluated from 0 to 1. The theta, that's from 0 to 2 pi, okay? 1/2 minus 1/4 minus 0 minus 0, so 1/2 minus 1/4. The theta, there is a constant one, excuse me, 1/4 times theta running from 0 to 2 pi, and the answer is pi over 2, 2 pi over 4, or pi over 2. Any questions? Sorry? That was directed towards me. So let's now evaluate this integral, example 2. Evaluate x plus y over r, where r, now be careful, it's defined in Cartesian coordinates, xy, such that 1 is less or equal to x squared plus y squared, less or equal to 4. And x is less or equal to 0. Okay, so let's see. The question is, how are we going to interpret this inequalities? Okay, we have 3 inequalities. Well, let's first sketch x squared plus y squared is 1, and x squared plus y squared is 4. Okay, so I have x squared plus y squared is equal to 1. Okay, the unit circle. And what does it say? That x squared plus y squared is greater than 1. How did I tell you? How are we going to solve this inequality? Well, just check, take any point, let's say the point 2, 0, right? Does the point 2, 0 satisfy this inequality? It does. So that means that we're talking about all the points outside of the circle, right? By the same logic, sketch the circle x squared plus y squared is equal to 4, which is 2 squared, right? The second inequality. That's going to give you this circle. Okay. So now let us just concentrate on this inequality here. X squared plus y squared is less than 4. Okay. And let's see what is going to be, what points in the Cartesian plane are going to satisfy this inequality. Well, check the point 0, 0, right? 0, 0 satisfies this inequality. So that means that this inequality are going to be all the points within the second circle. So the system, this system of inequalities yields what? That we are basically talking about the intersection of those two, which is this. Okay? And then the last one. The last one is that y is less or equal to 0. Well, is y is less or equal to 0, that means we are actually, finally, the region that we are talking about is this one. This is the region that we're talking about, okay? Well, let's express this in polar coordinates. First, r starts from 1 and goes to 2. R is between 1 and 2. Theta starts at pi over 2 and it's done by 3 pi over 2. Okay? So that means that this integral here becomes the double integral of x is equal to r cosine theta, y is equal to r sine theta, right? So x plus y is r cosine theta plus r sine theta. And now we switch to polar coordinates, so I have to multiply by times r dr d theta, where theta runs from pi over 2 to 3 pi over 2, and r runs from 1 to 2. And now you solve this. If you factor r from here, right, then you're going to be able to express this double integral as independent functions defined in theta and r. So that means that this double integral can be expressed as a product. Now let's go step by step. Pi over 2, 3 pi over 2, integral from 1 to 2. I factor r from here. Cosine theta plus sine theta times r dr d theta. R times r is r squared. Cosine theta plus sine theta dr d theta, right? This r and this r makes r squared. And now, because this is a product of two functions independently defined in r and theta, I can express this as r squared. That's the property that we learned last class, dr from 1 to 2 times cosine theta plus sine theta d theta from pi over 2 to 3 pi over 2. And now this is very easy. 1/3 r cubed from 1 to 2, and that's 7/3, right? 2 cubed is 8, minus 1 cubed is 1, 8 minus 1 is 7/3, times, let's see what is going to happen with this one, integral of cosine is sine of theta, integral of sine is minus cosine of theta, pi over 2 to 3 pi over 2. Okay, so we said that this one is 7/3 times sine of 3 pi over 2, sorry, minus cosine of 3 pi over 2, 0, minus sine of pi over 2, which is 1, plus 0. So this is -1, and this here is -1. This whole parenthesis makes -2, so the answer is -14/3. Any questions? Okay, if there are no questions, let's start with some serious stuff, okay? So example number 3. The double integral over the region R, r squared sine of theta, r dr d theta, okay? Where R is the region bounded by the polar axis and the upper half of the cardioid. R is equal to 1 plus cosine of theta. And now you can see how handy these polar curves become, okay? So let's sketch 1 plus cosine theta. So this was cosine of theta, right? -1 and 1, 1, 2, 3, 4. Okay, so this is cosine of theta. Cosine of theta plus 1 becomes okay, so that means that the radius r, let's say this is r, is equal to 1 plus cosine of theta. It's always positive, okay? So how is that going to look? This is 2 and 1. So 1 and 2. I start with theta is 0, the radius is 2. And then as theta goes towards pi over 2, okay, the radius shrinks to 0, right? Such that at pi over 2, such that at pi over 2 the radius is 1. So at pi over 2 the radius is 1, so this is the cardioid. right? And then it's symmetric over the x-axis. So it's like this. Okay. Okay. So what is the problem here? First of all, let's just define what is actually the region. This is the region that we are integrating above, okay? Because it says only the upper half, right? So I can zoom on that like this. Okay, so this is the region R. What is the problem here? The problem here is that the radius is not bounded by a constant, like in the previous examples. It doesn't go from 0 to 2. It doesn't go from 1 to 2, and so on and so on. It's bounded by this constant right here. Okay? So the radius is between 0 and 1 plus cosine of theta. And theta, as we saw from this graph here, if we're talking only about the upper half, then it's just from 0 to, this is not pi over 2, this is pi, sorry, this is pi over 2, my bad. From 0 to pi. There's nothing that I have to change here. The function is already expressed in polar coordinates, so the integral is equal to the double integral of r cubed, right? R squared times r cubed, sine of theta. But now be careful, it's a must that we first evaluate in terms of r, because r depends on theta, from 0 to 1 plus cosine of theta, d theta, and theta goes from 0 to pi. Here, although the integrand is expressed as product of two functions independent of each other, we cannot express this double integral as product of integrals because r depends on theta. So first I'm evaluating the integral of r, so that's 1/4, right? Integral of r to the power 4 is 1/4 r to the power of 4 sine theta r to the power of 4 evaluated from 0 to 1 plus cosine theta, and this is going to be I thought it's going to be a long process, but then I just saw the chain, the substitution rule. So this is 1/4 integral from 0 to pi sine of theta times 1 plus cosine of theta to the power of 4 d theta. Okay, and I take this, sorry, as my u. So 1 plus cosine of theta is equal to u. Du is equal to negative sine theta d theta, which brings me to 1/4 integral. When cosine is 0, I get 1 plus 1 is 2. And when theta is pi, I get 1 minus 1 is 0. Negative sine theta becomes negative du, and here I have u to the power of 4. Of course, I need to flip the order of integration in order to start with a smaller value and to end up with a bigger value. In doing so, I have to multiply the whole thing by -1, which will deal with this negative. So I get 1/4 times the integral from 0 to 2 u to the power 4 du, which is 1 over 4 times 1 over 5. Okay. U to the power 5 evaluated from 0 to 2, and that's 32 over 20. And then, I don't know, we can divide it by 4 maybe. 5 is 34, 2 divisible by 4? 8. 8 over 5. So this is an example where we have to, as you can see, r is not bounded by constants. It's bounded by a function in terms of theta. Any questions? Now I'm going to remind you one more time, right, that a volume of a solid bounded by the surface z is equal to f of x, y, okay, as well as the surfaces r is equal to a, r is equal to b, theta is equal to alpha, and theta is equal to beta, can be calculated, by using the double integral of the function expressed in r and theta times r dr d theta, and then r runs from a to b and theta runs from alpha to beta. Similarly like uh, integrals defined in rectangular coordinates. Okay, so let's do one last example for today. Find the volume of the solid that lies under the paraboloid z is equal to 4 minus x squared minus y squared, the one that we saw before, and above the disk x minus y squared plus y squared is equal to 1 on the xy plane. Okay, so what does this mean? It means that we're looking for right, so this is 1 2 3 4. So let's say that this is the paraboloid, right? And then we have an intersection of x minus y squared plus y squared is equal to 1. In the xy plane, that's the circle centered at 1, 0 with radius 1. Okay? But here, actually, that would mean, if this is 1, if I extend this to 3 dimensions, I'm going to get a cylinder. And the question is going to be, how much is the volume of this solid? That is very difficult for me to sketch, so something like this. Okay, that volume is going to be equal to the double integral of f of xy dA over the region R. Well, this is the region R. Okay, so the question here is, how am I going to express this in polar coordinates? Okay, let's see that. How is this circle going to look in polar coordinates? Okay, so this is x minus 1 squared plus y squared is equal to 1, right? Okay, so here expand this, x squared minus 2x plus 1 plus y squared is equal to 1. Okay, these two are gone, and you have x squared plus y squared. We did this kind of manipulations, but the other way around, where we talked about polar coordinates is equal to 2x, right? Well, now this thing in polar coordinates is just r squared, and this thing is 2r cosine theta. Well, now cancel these two, and you get r is equal to 2 cosine theta. So this is the equation of this circle right here in polar coordinates. The only thing that you have to do is now determine where theta is going to go. So theta is going to start with 0. So I get 2. At pi over 2, I get 0. And at pi, now this circle is going to be described when theta goes from 0 to pi. Guys, 1 minute only, please. Disaster had happened at my place, so I'm just going to finish this. The volume is equal to the double integral. This function expressed in polar coordinates is 4 minus r squared, right, times r dr d theta, where r runs from 0, right, to 2 times cosine of theta, from 0 to 2 cosine of theta, and theta runs from 0 to pi. Okay. And you can evaluate this problem. You can figure out that the answer is 2 pi over 2. Any questions? Questions, guys? Okay, you have